Hi everyone, and welcome to Calculus Lesson 5.5, Average Value of a Function. So we're going to start off by talking about how to find the average value of a function on a given interval. And what that means is that if this was my function, okay, and the interval is from A to B, and I took all of the y values from my function, every single one, even though there are an infinite number of them, we'll pretend I can do that, and I added them all up, and I divided by the number of numbers, that would get me an average y value. That's what we're doing when we find the average value of a function. We're finding the average y value between 2 points. Okay, so the way we do that is we find the average value, and this is how we note it. This is the notation for it, FAVE, is equal to 1 over the endpoints of the function that are subtracted. Okay, so b minus a, so those endpoints, times the integral from a to b of the function with respect to x. So let's do an example of that to see if we can make that a little more clear. So example 1 says find the average value of f of x equals 1 plus x squared on the interval from -1 to 2. So what I would do is put this into my formula. It's the integral from -1 to 2 times the function with respect to x. Now in front, I'm going to do 1 over the b minus a. So 1 over 2 minus -1. Okay, so this simplifies to 1 over 3 times the integral from -1 to 2 of 1 plus x squared dx. Now I'll do my antiderivative. I get x plus 1/3 x cubed evaluated from -1 to 2. And don't forget about that 1/3 in front. Sometimes I forget it. And then I have to go back and double check my answer. So now I'll put in 2. I get 2 plus 2 to the third is 8. So it's 8 divided by 3. And then it's minus. And then -1 plus 1/3 times -1 to the third, which is -1/3. And don't forget that 1/3 that was in front. Common denominators, this would be 6/3 plus 8/3 minus 3/3 negative minus 1/3. Again, still multiplied through by 1/3. So this is 14/3 minus -4/3, which is 18/3 times 1/3, which is 18/9, which is 2. So the average value of my function is 2. Okay, so finding the average value of a function is as simple as just putting in the numbers you're given and doing the integral and finding out what it actually equals. So the next thing we have to talk about is the mean value theorem for integrals. Okay, and it is linked to that average value function. Okay, so it says if f is continuous on the interval, then there's going to be a number c in that interval. So there's going to be an x value in the interval such that my average value is equal to that function. So notice they've given us two definitions here. F of c equals the average value, which is this. And they've also given us this. What they've done is on both sides of the equation, ignore this part here, they've multiplied by b minus a on both sides just to get rid of this fraction here. So f of c times b minus a equals the integral from a to b of f of x dx. Now let's take a look at what that would mean for us graphically, because that kind of helps to think of it in the graphical representations. Oops, looks like I can't keep that up. Okay. So remember, the integral from a to b of f of x dx is literally the area under the curve. So it's like literally this blue shaded region here. Okay? And what our mean value theorem for integrals is saying is that somewhere on this curve, there's a value c that's equal to the average value of that function. Okay? Now, if I make a rectangle that is this distance long from B to A, that's the length of the rectangle, with a height that is that average value, that's what this is, this height. So if I multiply length times height, it's going to equal the area under that curve. So it's helping us to make a rectangle that has an area that's equal to the actual area under the entire curve. So basically, like, this portion right here is going to equal this area up here. Okay, and they're going to cancel each other out. So I've basically like taken this area and flipped it over. Okay, but basically the area of my red rectangle is going to equal the area under the curve. That's what the mean value theorem for integrals is saying. It's helping you find that value c, that if I was to put it in, I would get that area. So let's take a look at example 2. Let me bring back my example 1 here. I'm going to note that the average value was 2, and we're going to do the mean value for integrals based on this previous question. So they want us to find all values c such that the mean value theorem for integrals is true. Okay, so that's what they want us to do. So all I'm going to do is I'm going to say my average value, that's this part, is going to equal f of c. Okay, so my average value was 2, and we found that in example 1. So I'm going to put 2 here, and it's going to equal f of c. So when I do f of c, all it does is it changes all the variables here to be c's. So I have 1 plus c squared. Now I'm just going to solve to find out what c could be. So I'm going to subtract 1 on both sides. And then I'm going to do the square root on both sides to get c alone. So it's plus or minus 1. Now the last thing I need to do is take this and make sure that both of those values are actually in this interval. Now notice this is a closed interval, so -1 is included, and +1 would be in the interval. So both of these are going to work as my values for c. Okay, so that's it for the mean value theorem and the average value on an interval. In the next video, I'm going to do an application question, and I'm going to do another average value question where we're going to be using some substitution to solve. So I'll talk to you soon, and let me know if you have any questions about what's going on.